I feel bad for the refs though, like the refs need to have something.
Yeah, I have no idea either.
He's making a joke that we do it around.
Yeah, I'm gonna burn out. All right, so yeah, there, I'm recording now. So so this is what we're doing. This will be the last formal sort of math lesson until I see some of you next year or whenever for advanced math. But this will be it for this year. So try to get through this as efficiently as possible. So I will now tell you this. So again, we're taking notes and we're doing it in the form of doing problems off of assignment number 59. Can you guys, I mean, not that do you answer this or not? I don't know. Can you tell me something that is true about all of the problems, problems 1 through 18? Swaggy B? Bracey, what'd you say? Right, and that's a big deal. You learned back in grade school that to add or subtract two fractions, they have to have the same denominators. And so there's not a lot going on. You should be able to plow through problems 1 through 18 relatively quickly. I did select 3 of them for us to do as notes. And again, I picked these for a reason. I don't know if it was like super scientific, but I felt like this was a good representative sample. So we're going to do problem 1 first. And what we see here is that we have 2 fractions and they have the same denominator, and someone's asking me to add them and subtract them. Listen, what we just got done doing, and you guys did very well on those quizzes, by the way. We don't care about whether or not the denominators are the same when we multiply and divide, right? It's not about that. It's about factor and cancel and simplify. This is all about the denominators. And so the first 18, the fact that they're the same on the bottom means we just have to add the tops together. So this is not, the first 20 minutes of this assignment is not a representative, like an accurately representative sample of what we're going to learn. Pretty easy, huh? So if we just take the tops and we add them together, which is what we do, what do we get? We do. So we wind up with 6x minus 4. And what will the bottom be? Good. Remember, we do not change the denominators. When you add 2 fractions with the same denominator, the denominator just stays the same, right? Like 3/10 plus 1/10 still equals 4/10, right? Reduce whatever. But the point is the denominators do not change. Yes? Yeah. Remember, this is the same rules apply. Like, don't forget here, I'll go back to my desktop and bring up Cancel Kitty again. The same rules still are stuck in our heads that, like, even though we're tempted to reduce things, we cannot, you can't pluck something out of an addition or subtraction problem, like one big clumpy factor thing, and just selectively reduce it. Doesn't work that way. So despite the temptation here, this is the best we're going to do. Got it? All right, the next one I chose for us is number 6. And I'm copying them onto my paper, my digital paper, just because I'm presenting and making a video. So like, I would understand if you guys, as I said the last time we did this, if you don't copy it, because you've already got it there, I maybe just put something on your work page that will sort of transition you into doing the problem. What changes in problem 6? It is, and listen, I've heard this speech before, but I'll never not say it. Subtraction changes everything. It's huge. The miss rate goes from, like, on that first problem, I put this on a test, the miss rate is like 1 or 2%. The miss rate, honestly, on this goes up to like 30%. And it's interesting just because, like, we, no matter how good we get at math, we still think like maybe we can overlook simple things. Why is that minus so important in the middle? We're on number 6.
Oh, I meant x. And the x minus 3.
Well, I mean, yeah, it changes the x minus 3 into minus x and plus 3. So like everything feels the impact of that minus. So I mean, take it or leave it. It's just advice. But when there's a minus, maybe take pause, slow down a little bit, and make sure you distribute that negative sign correctly. So on number 6, so we have 2x plus 3 on the left side. Over, I should have done this a minute ago while I was yapping, sorry. Minus, and then the top is x minus 3 over x plus 5. So, I mean, this being an Algebra 2 class, I don't know that I have to go super slow with this process, but we do know that the bottom is going to be x plus 5, right? Remember, the bottom doesn't change. And then the top is, how many x's will I have? Just 1x. And what will my constant term be? Plus 6, very good. So you can imagine how easy it is for someone to look at that and say, oh, the 3's cancel, but that's just someone being a knucklehead. Remember, this minus 3 right here, I'm going to circle it, is not actually a minus 3 anymore because this minus or this negative comes in and smacks it. So any questions thus far? Okay, the last one in this section was number 13. So again, let me just copy it down real quick. 5x plus 1 over x squared minus 64. And this is a subtraction. Bottoms are the same, of course. Again, anywhere before problem 19, your bottoms will be the same, which is nice. What do we know the bottom of our answer is going to be? And I know there's at least 3 of you in this room right now just chomping at the bit to ask the essential question. And that question will be ready here in about 30 seconds or 20 seconds. What is the top going to be? Yeah, there's 5x minus 4x, which is 1x, just x. And then 1 plus 7 is 8. Do you see it?
No.
Only if you want to kill that kitty. Come on, this is one concept and topic that listen, I'll keep saying it and saying it and saying it, but you have got to. The rules don't change today. Like, we don't just abandon this. We don't murder kitties, bless you, just because we've changed sections. Listen, that 8 and that 64 are not takeable, cancelable, because they are parts of subtraction and addition problems. They are not factors. However, anyone see it? Good. Yeah. So let's, for those that didn't quite catch that, this is where we, and it happens, I think it starts happening right around problem 12 or so is where you got to start paying attention to what we're about to do. The bottom should just be standing out to you like waving a red flag. Like, look at me, I'm a difference of 2 squares. Not saying that it will always bear fruit, but in a case like this, if I factor the bottom like I should into x plus 8, x minus 8, now I expose, I don't know if this is a word, cancelability. That should be, I think that's a word. That felt good coming off the tongue. Right. And good job, Ellie. You had that one nailed. So it winds up just being nothing left on top, essentially, which winds up being 1 over x minus 8. So we're still kind of in the warm-uppy section. Anywhere 1 to 18 is going to feel pretty warm-uppy, but still kind of be vigilant. Be on the lookout for those factorable things, because if something's factorable, maybe factoring it will produce fruit, you know, some progress to be made. So that's all I'm going to do with you in the top section, okay? So that heads us on to the next section, and the first one I want to do out of that is problem 20. So this is where the lesson really starts. I mean, what happens now is the denominators are not the same. And so we know from back in the day that in order to be able to add 2 fractions together, we have to make the bottoms the same. Like, if they're not, it would be no different than, and I'll give you a very simple example to sort of match this. You may not see it, but it's kind of the same idea. So if I gave you like 2 thirds plus 7 twelfths. Right. And so someone taught you, again, long before you even knew I existed. This would have been years ago when you were in like 4th grade. Someone taught you that you have to match denominators. And sometimes you have to change both denominators, but it's sometimes also one of the denominators is already the least common. So like in this case, the 12 is the one that the 3 can go into. So I would take the first fraction and I would multiply its top and its bottom both by 4, right? So we're going to employ that exact same elementary school logic to the white problem and ask ourselves, what is the common denominator? No. So what we really need here, and this one question is going to be at the core of our entire time together now for the next 5 or 6 school days. The question is, what is the LCD? And this will really be what occupies most of the time now for the rest of the lesson, is me trying to explain to you how to find a least common denominator. So the least common denominator is a package of factors that can be used to build both denominators. So if you think about it, like this is always the hardest part of the explanation. I've tried using the analogy of Lego pieces in the past, and some people I think it makes sense, and some people it doesn't. If I took a little baggie and I put think of factors as little building blocks like Legos. If I handed Sutter a little Ziploc baggie and it had this in it, and I said, okay, Sutter, you may only use the pieces in the bag, but you have to build this design and then put the pieces back in the bag and then hand it to your brother and he has to build this design. The fundamental question for us becomes, can he do that? Could Sutter do his thing and then hand it to Cooper and have Cooper do his thing? Is that possible? No, there's not enough pieces in the bag, right? So like Cooper would say, bro, you didn't hand me enough. Like there must be some pieces. Like, I don't know if you've ever done that before. Like if you're a Lego person, you always, you pay a lot of money for Legos. You hope when you look at the manual that all the pieces you need are there, right? So Cooper would say, hey, I need what? What is Cooper missing? He doesn't have a 5, does he? So the first thing he notices that he needs a 5. He says, there's no 5 in this package, so you need to add a 5. And what else does Cooper need to build his design? He needs another X, correct? And so when we talk about what is a least common denominator, it's literally the most efficiently built package of Lego pieces that can be used to construct both denominators. No different than in that last problem where the least common denominator was 12. A 12 has exactly what it needs to build both a 3 and a 12. It has a 2, and a 3. That's what you make a 12 with, and that's what you can make a 3 with. So in light of that, if we know that the least common denominator is 5x squared, the question now, and this will be all you do now for the next 3 days, the question becomes, what do I do to make sure that both of the denominators say that? Well, let's look at the first fraction. Obviously, his bottom is not okay, right? What is the bottom of the first fraction missing? It's missing a 5 and it's missing an x. So we're going to take the first fraction and we're going to multiply its top and its bottom both by 5x. What is the second fraction's bottom missing? Nothing. So you'll find this often to be the case that one fraction remains unmodified. Just like in that last problem, I shouldn't have erased it, the 4th grade problem. We didn't have to mess with the fraction that said 7/12 or whatever because its bottom was already good. Mm-hmm.
26 and the 5 is 23. I was not with the 7.
Don't get ahead of yourself, okay? So are we okay on the purple thing so far? Mission 1 critical is make the denominators the same, right? And your 4th grade teacher would tell you the same thing, make the bottoms the same. So by multiplying the top and bottom both by 5x, what I have now is matching bottoms. So let's proceed and do these yellow problems, which really it's not very exciting. What is 6 times 5x?
30.
So we have 30x over 5x squared, and you will generally not do this step. I'm only doing this for instructional purposes. 9 going forward. We'll probably skip it every time. Plus 7 over 5x squared. And what you see now is that it looks exactly like any of the problems in section 1 through 18, problem 1 through 18, because the bottoms are the same. So we can now hop ahead to our final answer, which is 30x plus 7 over 5x squared. And any temptation you have to reduce the 30 and the 5, smack it out of yourself. Any temptation to reduce those x's, smack it out of yourself. Remember, those are not like factors themselves that are cancelable. They're parts of something else. Mm-hmm. Right, this fraction, let me put a box around it just so you can see. This fraction is unmodified. We don't mess with that because its bottom is good, right? Only mess with fractions if there's a reason to. So far, so okay. All right, let's head down to 25. And I picked number 25 just because I knew that there'd probably be some questions about problems where one of them is not a fraction. So what, oh yeah, this is 25. I should have said that on here, like on the page. So 25. So we have like a whole numbery sort of vibe going with 2x, and we're going to add it to x over y. So simple strategy here would be what? Yeah, good math instincts. If something's not a fraction and you want it to be, just make it one. So we could take the 2x and just modify it and make it quick 2x over 1. At this point, I wouldn't encourage you to have done two things. Oops, apologies for that, 2x over 1. I wouldn't encourage you to do two things at once. Just make it over 1, call that good, and then let's have one. So what is the least common denominator? Just y. So again, there's this idea that one of the fractions already has what we want and the other does not. So if the least common denominator is just y, then we just ask, this is what we do. We ask ourselves, what do I need to do to that fraction? But what do I need to do to that fraction? Yes, it's just y, right? What's that? Oh my God, I should have seen that coming. Yeah, that was a, you played that, didn't you? From the start. Well played. Good job. It's never disappointing. Hi. Right. So again, we're back to the idea of let's look at each fraction and say, what does it need? And the first fraction doesn't have a y on the bottom, so we very simply multiply its top and its bottom both by y. And yeah, that gives us, and I am going to skip a step this time. I don't feel like I need to reconstruct it every time. So like here, I would just personally jump right to the answer, which is 2xy plus x all over y. Done. It's like you spend the last 2 weeks of Algebra 2 just combating the instinctive urge to cancel things out that you're not allowed to cancel. Those y's are just like, come on, come get me. And you're like, nope, 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 nope. Not going to do it. You're part of an addition problem. So. Good there. That's all I had from that section. Again, that section runs from 19 to 29, and those are all pretty much the same sort of vibe. Like one fraction has a bottom that can be made into the other fraction's bottom. So that leads us to the next section. And if you weren't paying attention, this section runs from problem 30 to 42. So we're going to start by doing 33. Why not? So in question 33, you can see things are starting to look more complex. But as was the case in the last section, those of you that are good at factoring will be rewarded. So if you were copying this, you'd probably be factoring as you go. Again, for instructional purposes, I'm just copying it down so that if anyone were watching this video, then they could see like just what the original problem was. So now begins the real sort of, I think at problem 30 is where the real sort of assignment, here we go now. This is where factoring the denominators becomes essential because I can't tell you what the least common denominator is until I see what the factors of the least or of the factors of the denominators are. Like, okay, so for example, if it were like in 4th grade and you gave a decent math student these. It doesn't matter what's on the top. Let's just do 3/8 and 1/12. Who cares? But you guys know instinctively that those both turn into 24, right? You just know it. But at its core, the reason the answer is 24 is because if you break the number 8 down into its bare bones, buck naked DNA, the number 8 is 2 times 2 times 2. If no one ever taught you this, let me be the first to teach you this in an 11th grade math class. This is how this works, just basic number theory. And the number 12 at its core, buck naked DNA, is 2 times 2 times 3. We call those prime factorizations. So again, I use the analogy of my stupid Lego pieces, and I ask myself, okay, if I handed a little Ziploc baggie to Sutter and said, Sutter, you need to build this, and then put the pieces that you use back in the bag and hand it to your brother, and then Cooper, you need to build this. What would I place in the bag? What do I need in the bag so that each guy in his own time can build what they need to build? How many? You're exactly right. So in order for this to work, and again, your 4th grade teacher probably didn't go into this much number theory detail with you. I don't know, maybe they did. But at its core, what's really happening here is I need the requisite number of pieces. I need a 2, another 2, and another 2. And you might say, well, Cooper doesn't need 3 2s. Don't care. Sutter did, so it's got to be in the bag. And then you might say, but Sutter didn't need 3. Doesn't matter. Cooper did. So we think about what are the requisite pieces to build both buildings at different times. And that's where the number 24 at its core really comes from, is it's just all that buck naked DNA pieces put together to build a number, what we call a common denominator. So the same logic is about to apply to us here, but I can't employ any of this thinking until I can see what the factors are. I can't see the DNA. So help me factor this bottom over here. What do we get? Nice. And then, of course, we need to factor this bottom over here. What does that factor into? Good. So again comes the piece about the little dumb Ziploc baggie. Are you picking up the vibe on the whole the Lego analogy thing? Is that clicking at all? So like I have to ask myself, okay, and I'll keep picking on the Allen boys. Like if I hand Sutter a little Ziploc baggie to build his red denominator, just him, not even thinking of his brother, what does Sutter need in the baggie? He needs an x plus 2 factor, and he needs an x plus 3. So if Sutter zips those pieces back in the bag and then hands them to Cooper, does Cooper have what he needs in the bag? What's he missing? Correct. And therein lies now how you build the least common denominator. The least common denominator is the most efficiently built package of Lego pieces that will satisfactorily build them both. Okay, you might have had someone teach you in the past something called crisscross applesauce. Have you ever heard of that before? Like 5 6 plus 3/8. Has anyone ever taught you crisscross applesauce? Like where you multiply? Yeah. So I just don't want you to think like that you know a secret. Don't ever use this on this, because oftentimes it won't give you the least common, and then you're going to wind up with things that you don't know how to factor. I don't know how to factor. Okay. So like if you've never learned this before, I'll just teach it to you now so that when someone shows you, you don't think I was holding out on you. So some people learn factoring by multiplying the top of this one by the bottom of this one. What's 5 times 8? 40, right? And then they multiply the top of the second one by the bottom of the first one. What's 3 times 6? And they go, oh, well, this always works, right? And this, it's a totally inappropriate way to work with fractions, right? It's a bailout method. It's terrible, and its effect, it'll work more with elementary school fractions, but when you get to high school, we start multiplying inefficiently, and our bottom becomes like this 5th degree unmanageable polynomial. So if you think of that and think, why didn't he show me that? There, I just did. Don't do that. Okay, we're always going to look for the least common. 48 is obviously not the least common denominator of 6 and 8, and like I said, in 4th grade that wouldn't get us in trouble because we could just reduce it. In high school, we won't know how to reduce it because we'll see something to go, I don't know how to factor that. And that's your fault for doing the crisscross method. It's ghetto. Don't do that. What's up, Tristan?
The Boolean factors on what the X.
So we're back to the problem here now, and it's time to look at each fraction and do what we always do and say, what is the bottom of the fraction missing? So I'll point with the green arrow to the first fraction and just ask you, what does the bottom of that fraction not have? Correct. So we're going to take the top of the first fraction, and I'm gonna, I guess I haven't used yellow yet. So anything I write in yellow now is my making the bottoms the same step. Are you ready? So we're going to take the top of this first fraction and we're going to multiply by what its bottom needs, which is x minus 2. Please note that I am not going to do it on the bottom because this is the part of the lesson where I always decide I'm getting kind of sick of it. So we understand that legally we are multiplying the bottom. We know what the end game is here. So let's look at the second fraction. What is the bottom of the purple denominator? What's it missing?
Yeah.
Right, so we're going to take the top and we're going to multiply it by x plus 3. Got it? Okay, so where we're at in the process right now is we're going to write out where we currently stand with the answer. And the answer currently stands like this. We have x minus 4. I'm sorry about that. Nope, take that back. Fix that. I want to multiply out. Man, I wish I had more colors. Let's take the green box and multiply it out. So we're going to get x squared minus 6x plus 8. Then I'm going to switch to a red box. And let's multiply out the red rectangle. What do we get? Plus 2x minus 3. And then all of this, let's understand, is going to be over the least common denominator. And what again is the least common denominator? Nice. So what happens now is we clean up the top, and there's always an end game to this. It doesn't happen a lot, but sometimes what happens is if I now simplify the top, combine like terms, I might be able to refactor in the hopes of exposing a factor that's in common to the bottom. So let's just do some basic like beginning of the year algebra 1 stuff. If you combine all your like terms on the top, what do you get? We're not multiplying. Thank you. Voice of reason. Remember, everybody, an x squared plus another x squared is just 2x squareds. Minus 4x plus 5. Thank you. So my question at this point is that factorable? And the answer is, it's not. And I've said this on many different occasions, but you'll all hear it when you're darn good and ready. This is a great time to know how to tell. Is something factorable? Take 2 times 5. What do you get? Are there any numbers that multiply to make 10 and add to make -4? Then it's not factorable. So we now know that the final answer to this problem is going to be 2x squared minus 4x plus 5 over x plus 2 times x plus 3 times x minus 2. You will come to really love the problems where you get to that stage and the top is factorable. And then you realize I just made a huge, like, it feels good. Like yes, but in this case, the top's not factorable, therefore nothing cancels. Yeah. No, you do not. That's a great question. Because I respect you and do not want to emotionally harm you, I'm not going to ask you to re-multiply out things that are as annoying as the bottom. Multiplying the bottom back out would do nothing but make you and I have a less quality relationship. You would resent me. You might do things like look up my address and decide to come throw eggs at my front door, things like that. So no, we're going to agree that things like this can just be left like that. There's no benefit to multiplying that back out. So, good news. Okay. All right. Next one we're going to do is 39. So we have 3x minus 1. And you'll notice I am going to start to factor. Again, it's a recording, so maybe I shouldn't have said you'll notice I'm going to. You should be getting ahead of me in factoring. How's that? Again, I want the original problem to be on the recording. So, but you should already be factoring like the bottom of the first fraction. How's that? So hop on ahead. So this is the original problem. I hope I'm copying the right one. It's really easy when you go back and forth to let your eyeballs wander. I was telling someone you take like a little note card and like cut a little slit out of it and like, you know what I mean? And like move it down your paper because your eyeballs are going to like just now I was like, am I looking at 38 or 39? So you know what I'm talking about? Like just cut out a little notch, like the old decoder thing. All right, so now I'll get caught up. So yeah, just factor. So the first fraction is actually 3x minus 1 over x plus 3x minus 1. So I can erase that now because it was on the video. And what does the second one factor into? Nice. So let's see if the last 10 minutes served a purpose. Can you guys tell, just from without talking about Legos, what the least common denominator is going to be? Yeah. So if I build a little Ziploc baggie and I package in an x plus 3 and an x minus 1, and if you didn't figure this out the first time, by the way, the most efficient way to do this is to just build one. Just build it, because you know like Sutter's going to need an x plus 3 and an x minus 1, right? So throw those in the baggie and then just ask yourself, what do I have to add to make his brother happy? And his brother would get the baggie and go, well, thanks for the x plus 3, but I'm missing my x minus 3. So that's the quickest way to spot one, build one, and then just fill in the gaps. Got it? All right, so let's take now and do what we need to do. We know we need to modify each fraction. So like the first fraction, what's its bottom missing? It doesn't have the x minus 3, so we're going to multiply like that. Make sure you use parentheses. Second fraction, what's its bottom missing? Nice. All right, so we're going to take a moment now and do some basic math, basic like beginning of the year algebra 1 sort of stuff. So we're going to first multiply the green problem over here. What do we get? Minus what? Minus 10x. Okay, that's just the outside ones make minus 9x, the inside ones make minus 1x, so minus 10x. And then at the back, we have a plus 3. Everybody okay with that? Okay, how about the red problem? Or let's do purple. What's the purple problem going to equal? Good. Nothing to it, right? Now this becomes a very missable problem, and it's all because of something that I'm going to circle in red. That guy is a little demon. He's a little grade killer, because he's going to get his little tentacles not just into x squared, but he's going to negativize that, and that, right? You with me? Everything changes, yes. So really, the second half of this problem doesn't say x squared plus 3x minus 4. It says minus x squared minus 3x and plus 4. And that's the step right there that usually eats people's lunch. That's where we separate like some A's from some C's on a quiz right there. So that's what the tops are looking like. All right, let's clean it up. Put your like terms together. What do you get? Nice. Bless you. And again, I'm going to look and see if this can be factored, and I'm going to do the factoring test for it. And if you multiply the front number, which is 2, and the back number, which is positive 7, what's 2 times 7? Are there any numbers in the known universe that multiply to make 14 and add to make negative 13? not if they're both negatives, which both negatives are both positives. So again, our answer, pretty anticlimactic, is going to be 2x squared minus 13x plus 7 over the LCD. And no, you cannot just write LCD. Like I've had someone actually ask that in the past. So you actually have to put it in.
What do you think?
That's all I wanted to do from that section. And like I told you, this is going to take a while. We still have 2 to go and we're up against the clock. So I want to do 44 and 48. And again, we walk away from this and say, God, that took forever. But the good news is we know how to do it and there's 9 problems done. Woohoo! And we still have 2 whole class days to work. Life is good. All right, so the next one up is 44. We are now in the bottom section of problems, which was from 43 to 50. And really all that changes here is that we've got 3 fractions now instead of 2. So I'm going to go ahead and copy the problem down as 3. It doesn't say 3 over 1, but I'm going to put 3 over 1, just save some time. Oh, I knew that. I was testing you. That's a lie. So problem 44 is 2. So 2 over 1 plus x over x minus 3. Get to the chopper. Can you guys hear it out there? There's a chopper. Right, bottom right. Yeah, so this bottom right fraction you see is a difference of squares. We're going to factor it just right out of the gate into x plus 3x minus 3. What is the least common denominator? And? Yeah, I mean, the bottom line is I ask myself, what would I need in a little baggie to be able to build them all? You don't need anything to build a 1. Right? But I do need an x minus 3 to build Sutters, and then I need an x minus 3 and an x plus 3 to build Coopers. So therein lies the package. So what does the first fraction need? What does this bottom need? Yeah, it needs both, doesn't it? So just to save time, rather than multiply by it like that in that form, I'm going to multiply by x squared minus 9. Because I understand that that's, you know, what I'm essentially multiplying by. We're going to have to multiply back out anyways. The top you'll always play with and refactor if possible to expose things. What does the second fraction's bottom need? X plus 3, so I'll multiply the top by what the bottom needs. And what does the third fraction's bottom need? Nothing, it's good to go. Thanks for hanging with me this long. You guys are great. The fact that you're still answering questions 48 minutes into this, you're amazing. You're the best. So, all right, let's clean this up. So on the top, if we multiply out this red problem, what do we get? 2x squared minus 18. Okay, let's go ahead and multiply out this green problem. What do we get? Good job. And notice I don't have to worry about any signs this time. This is a pretty relaxing problem, right? And then I'm going to go ahead and just leave the third one alone because I never had to tinker with it. So it's just a minus 3. All right, let's go ahead and combine up some like terms. The last one is coming right up here. So we get 3x squared plus 3x minus 21. And I don't think there's going to be any meat on this bone. I think I've picked another one where there's really nothing going on here. So the only thing I could really say progress-wise about this problem is that I could pull a 3 out of the top. But it turns out there's no benefit to that because there are no 3s on the bottom, right? We're not allowed to look at those as 3s. They're parts of something. So it would be okay in a case like this to just leave it alone. Right. If it was going to like keep you up at night having the GCF on the top, you could pull it out. But again, no harm, no foul. All right, last one, guys, 48. What are some things that catch your eye? There should be 2. 4x squared minus 1 is a difference of squares. Let's get that out of the way right now. So what does that factor down into? What's the other one that by now ought to have caught your eye, Bryce? I agree. So we just know that 1 minus 2x, that should stick out like a sore thumb. Just no. So we're going to take and we're going to modify that one. And here's what I do. I'm going to take the negative. I'm going to make it red so you can see it. And I'm going to put it up here to the top. Okay, the negative has to go somewhere, but you don't want to leave it on the bottom. But since we're going to blend and mesh all the top stuff together eventually, it's probably good just to put it on the top right now. So take the negative, move it to the top, and now you're free to take the 1 minus 2x and reverse it like you wanted to this. Now it's time to ask ourselves, what's the LCD? And what is the least common denominator? Right, so we need to build 2x plus 1 times 2x minus 1. So what does the first fraction need? It needs a 2x plus 1. What does the second fraction need? It needs a 2x minus 1. And what does the third fraction need? Good job, guys. Let's finish this out. Timing was a little closer than I meant, but we got a couple minutes. Let's wrap it up. So for the first multiplication problem, the red one, we should get negative 10x squared minus 5x. For the second multiplication problem, the green one, now I'm going to get minus 4x squared, and I'm going to get plus 2x. And you might want to say, whoa, didn't you mean minus 2x? And no, I did not. That was very much by design, right? Because this minus that I'm circling in purple, remember, he affects everything immediately after him. So I did not want to write minus 2x, knowing I'd have to change it anyways. And then, of course, the 3 comes from the back. Let's clean it up. How many x squareds we get? How many x's? And plus 3. And this is all over 2x plus 1 times 2x minus 1. And I believe that yet again, we find ourselves unable to factor. So, yep, that's as far as we're going to go. Gosh, guys, thanks for sitting through that. Talk about using the whole hour. Remember, rest assured, tomorrow, full work day, Wednesday, basically full work day. So if you want to go home and get half a dozen of them done, all right. Get a dozen of them done, great. There are no bells today, but it is 9:44, so you guys can skedaddle.